go to page 8 in your packet, and we should have already gone over evaluating and adding and subtracting rational numbers. Looking at example 1, we're going to add or subtract with like denominators. For part A, it says to add the numerators and simplify. So we're just going to take 7 plus 3 over 4x. Because my denominators are the same, I keep it the same. And that's going to be 10 over 4x. Now you can simplify 10 over 4. What does that simplify to? Yeah, 5 over 2x. So that is my final answer. For part B, I just subtract 2x minus 5 over my denominator, x plus 6. Since these are the same, we keep it the same. And my final answer is just 2x minus 5 over x plus 6. For example 2, this is a little bit different. We want to find a least common multiple of two, expressions. So if you look at the directions up top, it tells you to factor the expressions completely, and then the LCM is the product of the highest power of each factor that appears. So looking at example 2, we're going to take each expression and factor. And then my answer will be the product of the highest power of each factor. So 4x squared minus 16 equals, I can take out a 4, and I'm left with x squared minus 4. And then x squared minus 4 is a difference of 2 squares, so I can factor that. So I'm going to say that's 4 times x plus 2 times x minus 2. And we are going to write 4 as 2 squared, but that won't always happen. It's only if it's a perfect square. So we're going to write 4 as 2 to the second power. Then I want to simplify 6x squared minus 24x plus 24. I can take out a factor of 6, and I'm left with x squared minus 4x plus 4. And then I can factor that to be 6 times x minus 2 all squared. And again, I want to factor and break apart the 6 to be 3 times 2. And then we'll have times x minus 2 to the second power. So from here, I want to take the first factor. So I want to take all of these and then add in whatever I'm missing from here. So I have a 3, so I have to put the 3 in, and the 2 I've got, x minus 2, I'll have to add this. So my LCM of these two things is going to be 2 squared times x plus 2 times x minus 2 all squared times 3. And I should have put the 3 at the front. So if I do 2 squared, then I'll have x minus 2 squared. From here, a shortcut or a little trick to doing this is going to be taking the first factor and then just adding whatever you're missing to get the LCM. So the LCM is going to be 2 squared times x plus 2 times x minus 2. And then look at this factor here, and what am I missing? I'm missing the times 3, I've got a 2, and I'm missing squared from the x minus 2. So now if I simplify that, I'm going to just do 3 times 2 squared, which is just 12. And then I'll have x plus 2 times x minus 2 squared. This is the LCM. We'll practice this again tomorrow if you're having a little bit of trouble. For example 3, we're going to add with unlike denominators. So this means we have to get the same denominator for both of these. In order to do this, I have to set this up and say 7 times the denominator of my other fraction, 3x squared plus 3x over 9x squared times 3x squared plus 3x plus x times 9x squared. And then we have the common denominator here. So from here, I'm going to simplify the numerator, just the top, and then I'm going to simplify the denominator and try to factor and simplify things. So I'll get 7 times this and times that, distribute, and distribute the x in here. So this is what we get in my numerator, and we leave the denominator the same. Now I want to take out the GCF from the top, and that's going to be 3x. When I do that, I'm left with 3x squared plus 7x plus 7. And I reordered these so it's in a nicer order. And then I'm going to also factor the bottom. I can actually factor this, what's in parentheses. I can take out a 3x, and I'm left with x plus 1. So I'm going to rewrite that in the bottom. I'll have 3x, this is times, and then x plus 1. From here, I can cancel some things out, which is really nice. I can cancel the 3x's out, and then I can rewrite my final answer to be 3x squared plus 7x plus 7, all divided by 9x squared times x plus 1. And this is my final answer. Moving on to example 4, we're going to subtract with unlike denominators. So this is similar, but instead of adding, we're subtracting. To start this off, I'm going to rewrite my values here. In order to do that, I'm going to say x plus 2, that'll stay the same. But then in the bottom, I'm going to factor out a 2, and it will be x minus 1. Minus, I've got negative 2x minus 1 in the top. And then I can factor that bottom part into x minus 1 times x minus 3. Now to get a common denominator, I see I have 2x minus 1 here, and I have x minus 1 times x minus 3 here. So I'm just missing the 2 in my second fraction, and I'm missing the x minus 3 in my first fraction. So when I rewrite this, I'm going to say x plus 2 over 2 times x minus 1 times x minus 3 over x minus 3. And then minus negative 2x minus 1 times just over x minus 1, x minus 3 times 2 over 2, because I'm just missing the 2. So I can rewrite this and as one fraction, and then we'll simplify. I'm going to FOIL the top, so I'm going to FOIL these two. Remember, or distribute. Remember every single part, so that'll end up being x squared minus x minus 6. And then I have minus, and I'm going to distribute the 2 into both of these. So minus, I've got negative 4x minus 2. All over 2 times x minus 1 times x minus 3. From here, I want to simplify the top and combine like terms. So I can combine negative x with negative 4x, so that's plus 4x, and I can combine negative 6 with minus negative 2. So I'm going to get x squared, negative x plus 4x is plus 3x, and negative 6 plus 2 is minus 4, all over 2 times x minus 1 times x minus 3. I'm going to factor the top and see if I can cancel anything out, and then that will be my final answer. So I factored the top, and then from here, what's going to cancel? Good, my x minus 1s will cancel, and then my final answer is going to be x plus 4 over 2 times x minus 3. Big Ideas might ask you to say what x cannot equal, and since we canceled out 1, we'll say x cannot equal 1.